All right, everyone, welcome back to another delightful lesson. So today we're going to be learning about U-Substitution. This is an extremely powerful tool. It's kind of like the Kanye West of integrals. It's the biggest tool we have. And whenever I'm looking at an integral that I don't know how to do, I'm not immediately sure how to proceed, a U-sub is the first thing that comes to mind. So here's what it's going to help us with. It's basically like the chain rule. Like we can do the integral of square root x, or we could do the integral of sine of x. Like these are integrals that we feel pretty comfortable about, but what if there's something else in parentheses? So what about integral of square root, 2x minus, oh wow, that did not turn out right. What about integral of square root 2x minus 4? Or what about the integral of sine of 3x? Like how would we approach those integrals? Basically like the chain rule, but for integrals. So what we're going to try and do is we're going to try to write the integral in terms of a new variable u. And the general strategy here is to take a complicated variable in terms of x and turn it into a slightly easier integral in terms of other one u. Okay, so let's go ahead and look at several examples, and I think this is a strategy that can really just best be served by looking at those. So suppose we have to integrate 2x times x squared plus 1 cubed. Here's a strategy that you want to walk through. The first step you need to do is find the part that you're going to change into a u. So find u. And u is usually going to be raised to a power or inside a function. And a good general tip for that is to look inside parentheses or where there probably should be parentheses. Okay, so in this part, we see that x squared plus 1, that's raised to power. It's not just x cubed, it's x squared plus 1 cubed. So I'm going to choose my u in this case to be x squared plus 1. All right, now the second step that I need to do is I need to take the derivative of your u to find du. So when I take the derivative here, du dx would be just 2x. So if I just solve for the du is 2x times the dx. So just kind of multiplying the dx to the other side. Okay, cool. So now that I have that, now what I'm going to do is I'm going to rewrite the integral in terms of u. So I'm going to take this integral in terms of x and dx, I'm going to write it in terms of u and du. That's my next step. So what I'm going to do here first, is I'm going to plug in the u. So if u equals x squared plus 1, instead of having x squared plus 1 cubed, I'm going to write that as u cubed. And then the fourth step is I'm going to put in the du. So I'm going to plug in the du by replacing the dx and any other parts that match. So what we've said is du equals 2x dx. So we're looking for somewhere where we have a 2x and a dx. So we have a 2x and dx. So those are both going to be replaced because it's they're all multiplied, right? Everything's multiplied together here. 2x times dx is going to be replaced just with a du. So that's this part. So what that's done is I've rewritten the integral as u cubed du. So we had the 2x dx became the du. And the x squared plus 1 cubed, that became the u cubed. And again, we found that du by taking a derivative of your u. Now at this point, you should say, bruh, this is a pretty easy integral to do. Because now all I have to do is just integrate my function and then plug back in for the u. So how do you integrate u cubed? Well, obviously that's just u to the 4. So u to the 4 over 4. So then how do I plug in for the u? Well, we know u is x squared plus 1, so I'm just going to plug this back in. So that's just x squared plus 1 to the 4th power divided by 4, and then still need the plus c. Okay, so that's the strategy there. I used a u sub to write it in terms of u, and I took the 2x and dx, that became the du right there. Let's do several more examples, and I think we'll start to see a pattern here. Okay, so suppose now we have to integrate a 2x plus 5 squared, and we're going to see another one here, another strategy here come up. Okay, so you have to pick your u, and the u, of course, is the part that's in parentheses, the 2x plus 5. Now the derivative of that is, okay, derivative of 2x is 2. So we just put the derivative and then write a dx afterwards. Just take a derivative and then put a dx after it. Okay, so now here's the deal, right? So we know that 2x plus 5 squared is going to be a u squared. But what about this? We don't just need a dx to replace. I want to be able to replace a 2dx with a du. So what I'm going to do here that's going to be a little more complicated is I need to match up the constant. So I'm going to multiply by a constant, which in this case will be a 2, to match what I need for du. So my du is 2dx. So what I'm going to do is I'm going to put a 2 right in here. Now, I can't just randomly multiply my integral by 2. But what I can do is I can multiply by 2 and then multiply by half to cancel as well. So I'm going to multiply by the reciprocal in front. So I'm not just randomly multiplying by integral by 2, I'm multiplying it by 2, and I'm multiplying it by a half in front. So I'm not actually changing the value of this integral. I'm just multiplying by 2 in one place and 1/2 in another place. Okay, so let's leave the 1/2 in front. And then the 2dx, that's going to get replaced with du. So now I've gotten to this point. I wrote my whole integral in terms of u and du. That's the goal. I don't want to have any more x in my equation. It's all in terms of u and du. And now I can do the integral. So now I'm saying chilling. So that's just 1/2 times u cubed over 3. So that's just going to be 1/6 times, and then I'm going to plug back in the 2x plus 5 cubed plus c. Okay, so the new trick on this problem was I needed to match up, I needed a 2dx to match up with my du, so I put a 2 here, I balanced the 1/2 in front. Okay, let's do another one here. So let's say we integrate cosine of 2 minus 4x. Now when you take a look at this kind of guy, you're like, okay, I don't just have cosine x, I have cosine of something else. That's your u. Your u is whatever that something else is, that 2 minus 4x. Okay, and then the derivative of that, the du, is negative 4 times a dx. Okay, so let's see. I'm going to write this like I know it's going to be cosine of u, but what do I do with the constants? Well, it's dx, I need a negative 4 dx. So I'll put a negative 4 in there, and then I need to balance with a negative 1/4. And I often just put that in front of the integral, right? It's a constant, I can pull it out. So I multiply by negative 4, I multiply by negative 1/4. So I'm going to have negative 1/4 times cosine u. The negative 4 dx becomes my du. And again, this is the point, right? This is what you're trying to do, is take your integral and turn it into a simpler one in terms of u. Now, I can go ahead and solve this. So I worked with the negative 4 and the negative 1/4. So now, the integral of cosine is sine, so negative 1/4 sine u plus c, also known as negative 1/4 sine, and then I'll plug this back in for the u, sine of 2 minus 4x plus c. Now, if I take a derivative of this in my head, I recognize that the negative 4 cancels with the negative 1/4. I just get back to cosine. Good. I checked by doing a derivative. So we're kind of doing the opposite of the chain rule here. Let's look at 2 more examples particularly here. Suppose we want to integrate 10 over square root 5x plus 1. So one tip I'll give you, to deal with a 10, just move the constant in front. So bring the 10 in front. So 10 times integral 1 over rad 5x plus 1. Okay. Now, if you want to pause this and try the U-sub on your own, it's not too bad. I'll give you a moment to do that. And welcome back. So now, the u is going to be whatever's inside the square root. It's kind of like in parentheses there. So pick the u to be a 5x plus 1. The derivative of that is just 5 times dx. Okay. So we need to put a 5 here by the dx. We need to put a 1/5 in front. And that's just multiplied by the 10, right? It's just a constant. So this will become 1/5 of 10 is 2 times integral 1 over rad u. The 5 dx all gets turned into a du. That's this equation. I just kind of substituted the 5 dx with the du. Okay, so then what you're doing is you're doing 2 times integral u to the negative 1/2 du. So that becomes 2 u to the negative 1/2. Let's see, add 1 to the power, u to the positive 1/2, balance of the reciprocal in front, and then plus c. So that's 4 and then square root 5x plus 1 plus c. Okay. So let's look at one more that I think is a little bit of a doozaroo here. Let's say we have to integrate 2 times sine cubed of x times cosine x. Well, you might be like, gee willikers, all those trig functions, what the deuce am I going to do? Well, let's think about this. Let's rewrite this. This is 2 times sine of x to the 3rd power times cosine of x. Well, that might be a good way to do this, because now you look at what's in parentheses. You're like, we have a sine x. That's my u. U is sine of x. The derivative of this is cosine of x dx. So I'm going to replace this part here with that's my du, right? This whole thing is the du. So this just becomes integral of 2u cubed du. So you don't actually have to do anything weird with the product, because the cosine x dx just turned into my du. And now we're like, this is just 2u to the 4 over 4 plus c. So that's just like 1/2, and then sine of x to the 4th power plus c. Okay, so those are just several different examples of how to do a u-sub. I know it seems a little weird, this idea of like changing the variable to make it an easier problem. The more you do these problems, the better you're going to get. So just do lots of practice, and the more you work on the homework is really going to help. One quick note. If you try and do something like this, like cosine of x squared dx, this does not work with a u-sub. And I'll show you why, right? You might look at this and be like, yeah, I'm going to try and do a u-sub, right? U equals x squared. But the derivative of that is a 2x dx. So now, you could put a 2x here, and you could put a 1 over 2x in front. But, you have a problem that you have this extra x. So, I can't deal with this extra x. And I think a good general rule is you cannot add in an x. You can add in a constant, but if you have to add in an x as part of doing your u-sub, it's not going to work out the way you want. So if you find yourself having to put in an x right there, and not just a 3/4 and a 4/3 or something, that's okay. But if you have to put in an x, it's not going to work. You're not going to find a way to do the problem. So there is a way to do that integral, but it's a little beyond this class for now. Anyway, that's u-sub. I'll talk to you guys soon. Thanks for watching.